Hi guys. I'm feeling really guilty that I've abandoned you yet again. I haven't really abandoned you. I'm right next door. I'm in Mr. Calford's room doing some work with our math learning team, which is all about sort of us teachers learning new and improved ways to teach math. But unfortunately, I'm not with you. So I left this lesson for you, and I hope it finds you well. And today, we're going to learn about parallel and perpendicular lines. This is lesson 4.4. So if you go up to our unit tracking sheet, I hope you keep track of your own as well, we're catching up with 4.4 here. So we went a little bit out of order. We did 4.5 and 4.6 ahead of it. And now we're going to come up and catch up with this one. So you can go fill that out. So here we are. So the whole idea with parallel and perpendicular lines is that today we're dealing with lines where we're talking about different special cases related to different lines and how the slopes relate to one another. So I thought we'd look at this example here. Well, first we're going to talk about parallel lines. And two lines would parallel if they never meet one another, even when extended to infinity. So two lines that run beside one another in such a way that they never meet. So I hope you see, looking at the example below, that these lines here are not parallel. Right? They meet. But I hope you see that these lines here seem to stay exactly the same distance away from one another. So if we extended these out forever and ever and ever and ever, they should never meet. They should run side by side just like that. They should stay the same distance away from one another forever. And what I want to do now is investigate if there's something in an equation that can tell us if lines are parallel or if they are not parallel. So I'd like you to take a minute and find the equation for all the lines on this page. And you can pause this video and go ahead and do that. There's 4 lines total, 2 in the not parallel example and 2 in the parallel example. So please go ahead and find the slopes and intercepts of each, and then write an equation for each. Oh, wait. Okay, so we're back. Let's talk about this red line first. And let's look here at it. And let's start by noting that for this line, b is equal to 1. That's the y-intercept. And here we have a run of 2 and a rise of 1. And that should tell me that for the red line, we get an equation of y equals, well, rise over 1 over 2. This line goes up. Its slope is positive, so we're going to not put a negative sign with that. 1 over 2x plus 1. And then for the blue line, let's take a look. Well, we have a y-intercept of b at negative 2. And then we have a run of 3 and a rise of 2. And so for the blue line here, we're going to get an equation y equals 2 over 3x minus 2. And there's not much information there for us, is there? We know these lines aren't parallel, and there's nothing interesting, especially about these lines that jumps out at us. Let's look at the example over here, because we've said these lines over here are parallel, so we might get a bit more information starting here. I'm going to start with the blue line. We're going to note that it has a y-intercept at negative 1. And let's see if we can get a slope out of this guy. I would say this one has a run of 3 and a rise of 1. Oh my, what's going on here? Okay, go away. That's better. And so for this one, the blue line is going to give us an equation of y equals, well, rise over 1. So 1/3 x, and the y-intercept is negative 1. And we have to note that this slope is descending, it's going down, so I have to make that negative 1 over 3. Negative because the slope is going down, so we could even say that. Negative slope. right now. Shayla is yelling at me. You missed that on the last one, and she's completely right. I did miss that on the last one, but I just went and fixed it. Let's look at the red line here. Here we'll see that this red line has a y-intercept at 2. This one has a positive slope. And specifically, we can find the measurement here because it's got a rise of 1 and a run of 3. And so our red line here will have an equation y equals negative 1 over 3x plus, what was the y-intercept, 2? Plus 2. All right, and these are parallel lines. And I want you to take a minute and take a look and see if you can maybe get a sense of what will make two lines parallel and what make them not parallel. So pause this video for a minute and talk about it amongst yourselves. See what you can come up with. All right, we're back. And I'm going to assume that you noticed, because I can hear from the next room Nathan yelling at me saying, I know, and he's really noisy because that's Nathan, always noisy. But he will have noticed a trend here. That over here, we have the same slope. But if we go over here, we have not the same slope. We have different slopes. So I hope what you take away from this, what you realize is that two lines will be parallel if they have the same slope. If you have the same slope, then you're moving at the same angle. And if you're moving at the same angle, you're never going to intersect one another. Whereas if you have different slopes, if you're moving at different angles, then eventually at some point the lines have to cross one another. So that's what we've taken away here. We've said two lines are parallel if they have the same slope. All right? And the corollary to that, the flip side of that coin, is that they're not parallel if they have different slopes. So first I want you to take a minute and just write the equation of two different lines that are parallel to the line 5x plus 3y minus 6 equals 0. And see if you can do it on your own. Pause this video. If not, we'll talk about it in a minute. Well, the first thing we need to know, of course, is this in the slope of this line. So let's convert this to slope-intercept form. And we have a whole lesson about that, by the way. If you're not sure how to do that, you could look at lesson 4.2, which is all about standard form, which is how I gave it to you here. And the third part of that lesson is about converting it to slope-intercept form, y equals mx plus b. But to give you the brief recap, we're going to solve this for y. And we're going to isolate y. So let's do that. If we have 5x plus 3y minus 6 equals 0, we want to get y by itself. On the first step, I want to get rid of this 6, so I'm going to add 6. And what I do to one side, I have to do the other. I also want to get rid of this 5x, because I want the y's alone, so I'm going to subtract 5x. And what I do to one side, I have to do the other. And when I've done that, the 5x's cancel, the negative 6 and the positive 6 cancel. I should be left with, that's right, Krish, 3y equals negative 5x plus 6. I hear Kenny back there just yelling, saying, oh, I know what to do next, I know what to do next. And he's going to tell me that I should divide both sides by 3. So I'm going to divide this side by 3. And then he's going to scream at me not to forget that multiplication and division are distributive. I have to divide this by 3 and this by 3. I have to divide everything on the right side by 3 because it has to be distributed, right? The 5x gets divided by 3 and the 6 gets divided by 3. And what does that leave us with? That's not what I want to do. Well, those cancel. And so I will be left with y equals negative 5 over 3 x, and 6 divided by 3. I could leave that as a fraction, 6 over 3, but of course we can simplify that. And Jasmine is telling me that that's 2, and Jasmine's correct. So there we go. So that is the equation of the line in slope-intercept form. And of course, the main takeaway from that is the slope. So we can now say the slope is negative 5 over 3. Now remember, lines are parallel if they have the same slope. So I just need to make two equations that have the same slope. But I can choose different b values, any b values I want. So we need two equations with the same slope. And these could be absolutely anything you want. I'm going to make two up right now. I'm going to say for the first one, negative 5 over 3x minus 4. And I'm going to say for my second one, y equals negative 5 over 3x plus 6. Nothing magical about those numbers. It's just important that they have the same slope. But we don't want them to have the same b value, because then they do the exact same line. And exact lines are parallel, actually, so that wouldn't be a wrong answer. That's kind of a boring answer. I just want to show this to you, that if I go into Desmos, I have to be patient, talking to the internet here. But we go to Desmos, it's in the projector mode. If I put the original line on there, which was what? 5x plus 3y minus 6 equals 0. 5x plus 3y minus 6 equals 0. It gives me a line. We can see that line right there. And then I should be able to put my two new lines I put on there, and they should be parallel. So y equals negative 5 over 3x minus 4 was the first one. So y equals negative 5 over 3 x plus 4. Oh, minus 4, sorry. Not plus 4, minus 4. And y equals negative 5 over 3x plus 6. And here are my lines. If you look, those three lines, sure enough, are parallel. They're never going to meet. They're never going to meet because they have the same slope. So there we have it. Now, the next question is write the equation of a line parallel to y equals 1/3 x minus 5 that passes through the point 6, 1. And I bet you can do this on your own. So take a minute and see if you can. And if not, unpause the video and I can help you. Right. The trick to this question is that the slope of this line is 1 over 3. So slope. And what letter do we use for slope, of course? Thank you very much, Caitlin. That's correct. It's M. So the slope is 1 over 3. Now, a new line has the same slope. But not the same b. So we're not going to worry about that negative 5. It has a different b. Otherwise, it would just be the exact same line. If it had the same slope and the same y-intercept, now we'd have the same line. So for a new line, We know that m is equal to 1 over 3. We know that slope's 1 over 3. And that it goes through a point. What point specifically? 6, 1. So we know how to solve a question when we have the slope at a point. And if we don't remember that, of course, we can go to lesson 4.5, which is finding the equation of a line, given the slope and a point on that line. We can walk our way all through that. I bet most of you remember that, actually. We're just going to start with the basic equation. Y equals mx plus b. Any line can be defined by saying that the y value of any point on that line is equal to the slope times that x value plus b. And we're just going to put numbers in here. We know the slope. Slope's a third. But we also know a point. So we know that we have an x value of 6 that works, that matches up with a y value of 1. And with that in mind, we can work on this equation. We can say that y value of 1 can be found by taking the slope, which is 1 over 3, multiplying it by the x value that works with that y value of 6, and adding whatever b is, whatever the y-intercept is. And now it's just about doing some simple math. 1/3 times 6 you can do in your calculator. Maybe you can do it in your head. But 1 would equal 1 times 6 is 6, divided by 3 is 2. So 1 equals 2 plus b. And now to solve for b, what do? Well, I can hear Ms. Ives in the back screaming that we have to subtract 2 to get rid of that 2. And I can hear Sam yelling that what we do to one side, we of course have to do to the other. And 2 subtract 2 cancels itself out. And 1 minus 2 is negative 1. So we get negative 1 equals b. And that means that y equals 1/3 x minus 1 is parallel to y equals 1/3 x minus 5. We know it's parallel because they have the same slope, and goes through. I should have left myself more room for this sentence, that's for sure. But it goes to the point 6, 1. And we can test that. I would always recommend testing something like this. Let's just put it in Desmos. Like graph. The original line was what again? It was 1/3 x minus 5. So the original line was y equals 1/3 x minus 5. What is that line? And our new line was y equals 1/3 x minus 1. And then y here. There we go. Now if we look, first and foremost, are those lines parallel? Yeah, you bet they are. They go exactly with one another. And the second thing is that our new line should pass the point 6, 1 if we've done it right. And sure enough, let's put 6, 1 on here, and we're going to see that it passes just beautifully to that line of ours. Oh gosh, golly me. I done screwed up. Okay. Sorry about that. So if we do 6, 1, I have to put that in brackets. And there we go. And that point is right on our line. So that means we made a line that's parallel to the original line. That blue line is parallel to the red line. And it does indeed pass through the point 6, 1. So we've done our job. We've done well. So those are just a couple examples of the kind of questions I could ask you dealing with parallel. But the main takeaway, 2 lines are parallel if they have the same slope. The other thing I want to talk about are perpendicular lines. And 2 lines are perpendicular if they meet at 90 degrees to one another. If they make a 90-degree angle. And today, I'm going to again ask you to kind of do a little bit of detective work. And your teacher will have given you protractors that you're going to use to do this, because we're actually going to find 90-degree angles. So I want you to start with the line y equals 2 over 3x plus 0. By the way, I just want to point out really quickly that writing the plus 0 here is actually a waste of time, but I just wanted to make sure you knew what to do with it. But really, this is just y equals 2 over 3x. But I put the plus 0 there just to show you, to remind you, that if there's no y-intercept shown, then the y-intercept must be 0. Anyway, so take a minute and graph that line. Pause the video. All right, and we're back. We know that to graph the line y equals 2 over 3x plus 0, we start at the y-intercept, in this case 0, b equals 0, and we're going to go up by 2 and over 3, get the next point, up by 2 over 3 to get us another point. Maybe I'll even go down by 2 and over 3 to get a point this way. And I'm going to make a line. And I want you to do this very, very, very carefully. If you didn't do it carefully the first time, I want you to take a moment and go back and just make sure you have a really nice straight line. Because the next thing I'm going to ask you to do is to actually get your protractor out and put it on here. So I want you to get your protractor out here and make a line that goes at 90 degrees to this. 90 degrees. And when you put the protractor on, it's going to sit like this. And I want you to make sure that line is right there like that. And you'll have numbers going from 0 to 90 to 180, 45, 135, all these ticks here, just like that. Isn't that beautiful? And at 90, you're going to draw a line. And there we go. So you're going to use your protractor to draw a perpendicular line. So this is what perpendicular lines look like. Now, if everyone's okay, I'm going to erase my protractor. You all had a chance to see my lovely, beautiful protractor, right? Oh. Okay, undo that. Okay, some of that mess has to stay. Now what I want you to do is find the equation of this perpendicular line. And to do that, well, I'm going to let you take a look. Okay, now we're back. To do it, we just look at rise and run. And here we have a rise of 3 and a run of 2. But we also have to note that the line is negative. And it goes down. That means our m is going to be negative 3 over 2. And the b is still 0, right? In this case. Well, it doesn't matter. But I want you to take a look. The original blue line had a slope of 2 over 3. And our new line, the red line, the perpendicular line, has a slope of negative 3 over 2. And these are perpendicular, which means they're at 90 degrees to one another. Now this one isn't quite as easy to pick up on as the parallel lines, but the perpendicular lines do have a relationship. If you look, 2 over 3 becomes negative 3 over 2. And we call this a negative reciprocal. A negative reciprocal. And that means we have to do two things. Flip the fraction, and switch the sign. So if the first slope was positive, the second one will be negative. If the first slope was negative, the second one will be positive. We switch the signs, and we flip the fractions. For example, just going to give a couple examples here. If the first one was negative 4 over 7, the perpendicular would be 7 over 4. Positive 7 over 4. We flip the fraction, and we change the sign. So, with that in mind, I want you to take a minute and write the equation of two lines that are perpendicular to this line. Y equals 3 over 2x minus 2. Pause the video. Okay, we're back. The thing to note is that the original slope was m equals 3 over 2. All right. So our new slope, the perpendicular slope, should be what? Well, it's a negative reciprocal. Negative reciprocal means we switch the sign. Since this one was positive, our new slope is going to be negative. And then reciprocal means we flip the fraction. So 3 over 2 is going to become 2 over 3. And now we just need two lines that have that slope, and they can be anything you want. The y-intercept doesn't matter. So we can have y equals negative 2 over 3 minus 2. We could keep the same y-intercept, in which case they're going to meet at that point. But we could use any y-intercept we want, actually. Do y equals negative 2 over 3 plus 6. All right, and let's take a quick look at Desmos and see if that works. New blank graph. The original one was y equals 2 over 2x minus 2. So y equals 3 over 2 x plus 2. There's our line. And I said that the new one would have to be y equals negative reciprocal. So we make it negative because it used to be positive. And instead of 3 over 2, now it's going to be 2 over 3. X, and the first one we said it could share the same y-intercept. And there we are. That's a perpendicular line. These make 90-degree angles to one another. If you put your protractor on there, somebody can even come up to the board and do that right now if they want. And you'll see that you get a perfect 90-degree angle there. Assuming the screen is calibrated correctly, which there's no guarantee it could be. And my next one was what? Y equals negative 2 over 3x plus 6. Sure, we could do that. Y equals negative 2 over 3 x plus 6. And you'll see, of course, you get another perpendicular line. This one has a different y-intercept. It intercepts at 0,6, but it's still perpendicular. You can come put your protractor up here, and again, as long as the screen is calibrated properly, that makes a nice 90-degree angle. So those are perpendicular lines. Now again, these are just the b values I used. Any b value is okay. The b value doesn't change the slope. So the b value doesn't change whether it's perpendicular or not. All right? And last question, write the equation of a line that's perpendicular to this one in standard form. Again, you're going to have to know how to handle a line in standard form. So take a minute and try that. All right, and we're back. And of course, you know that we need to put this in slope-intercept form. I.e., we need to put it in y equals mx plus b. And to do that, just need to solve it for y. So if we said 4x minus 6y plus 18 equals 0, and we want to solve this for y, we need to get everything else to the other side, which means this plus 18 annoys me. So we're going to want to subtract 18. And this 4x annoys me, so I want to get rid of it. The opposite of having 4x is subtracting 4x. But what I do to one side of the equation, I must do to the other. So I must subtract 4x, and I must subtract 18. Those will cancel, those will cancel. What remains? Well, 6y equals negative 4x minus 18. Same as folks, you're exactly right. And now Lane Delta is just champing at the bit to let me know that I need to divide this side by 6. And he is remembering that dividing by 6, that's distributive, right? That applies to the 18, but it also applies to the negative 4x. You have to distribute it. So that gets divided by 6, and that gets divided by 6. Those 6's cancel, and what am I left with? Well, I'm left with y equals negative 4 over 6 times x. And then negative 18 over 6, we can do that division. So negative divided by positive, so it's going to be a negative number. And 18 divided by 6, well, that's 3. And then I would note even further that this can be reduced. 4 and 6 are both divisible by 2. So we can simplify that fraction. Again, what we have here is totally correct. That's a nicer answer to say y equals negative 2/3 x minus 3. That's the original equation. That's the original. And what's perpendicular to it? Well, we have to change the slope. The slope was negative 2 over 3. The new slope is going to be the negative reciprocal of that. And that means changing the sign. So the opposite of negative is positive, so it's going to be a positive slope. And we have to flip the fraction. Instead of being 2/3, it's going to be 3 over 2. And so the new equation will be y equals 3 over 2x. And then any b value will do. I'm going to say plus 2. But again, the actual b value doesn't change whether it's perpendicular or not. So in this case, any b value works, because I didn't tell you the specific line I wanted. I just said any perpendicular line. So as long as we make the slope a negative reciprocal, any b value gives us that perpendicular line. And there we go. That's today's lesson. And your supply teacher is going to do a little bit of homework. And have fun with it. Good luck.